Hello students, welcome to Shri classes. Let us start lecture number 6, Arithmetic Progressions, CBSE 10th. Henceforth, you can find the lecture details and the topic and the standard on my right hand side here at the corner. Okay, fine. First part of the arithmetic progressions we have completed, and the second section is, if the arithmetic progression is given to you, how to find out the sum of first n numbers. Sum of first n numbers or sum of first n terms. Terms is more appropriate word. How to find out the sum of first n terms is the second section, and the sum of these numbers or the sum of the terms is also referred to as series over here. So let us derive the equation for the sum of first n terms. See, before the derivation, very interesting fact I would like to take you through your textbook. So let's see at the textbook here. Here, this is the name of the mathematician Carl Friedrich Gauss, a German scientist, a German mathematician and also called a physicist. A German mathematician and German physicist. He is called the Prince of Mathematicians. Along with Newton and Archimedes, he was one of the greatest mathematicians which we have found so far. Why did I refer to him? When he was 10 years old, a question was asked to him to find the sum of first 100 natural numbers. And how did he solve? Let us understand and then derive the equation for sum of first n terms. Okay, so the small boy, when he was 10 years old, he solved that problem, the sum of first 100 numbers, 100 natural numbers, basically 1 to 100. How did he found? Let us see, very interesting. It's really a good thing to learn from what this 10-year-old boy did that time. Okay, let's see that one now. So Carl Friedrich Gauss, he was asked this problem. Sum of first 100 natural numbers. Let us represent this sum as what he did. We'll see. He solved this problem like this. Let S represent the sum 1 plus 2 plus 3 plus dot 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 plus 100. Up to 100 he wanted to find. Once again, the same sum can also be written as 100 plus 99 plus 98 plus dot 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 plus 1. Both are same, no? Whether you sum it from 1 to 100 or 100 to 1, both are same. So he added these two. S plus S here, it is 2S. 100 plus 1, 101. 99 plus 2, 101. 98 plus 3, 101. Plus dot 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 plus 100 plus 1, 101. So everywhere you are finding 101. How many times this 101? 100 times. Because there are 100 terms here, and therefore 101, 101, 101, how many times we need to add this? 100 times. And therefore 2S equals 100 times 101. Correct now? 100 times we have to add, isn't it? That means 100 into 101, isn't it? So this S is equal to finally 100 into 101 divided by 2. 2 ones are 2 50s are, which equals 50 into 101, and therefore the sum of first 100 natural numbers is given by 5 ones are 5, 5 zeros are 0, 5 ones are 5, and this one. So this is how you obtained, how the physicist, German scientist Gauss obtained the sum of first 100 natural numbers as 5050. Is it not interesting? Now the same concept we are adopting to find out the sum of first n terms, sum of first n terms. Interestingly, 1 2 3 4 5 6 7, this sequence also represents an arithmetic progression. So if the list is given in an arithmetic progression, how to find out the sum of first n terms is the question, and we have to solve a lot of numericals on that one. First, let us derive the equation or expression for sum of first n terms, and then we will use that formula to find out the sum of first n terms for a given arithmetic progression. Okay, fine. So no need to note down this. I'll continue. On the similar guidelines, we'll try to find Sn, which represents the sum of first n natural numbers or first terms, basically. The sum of first n terms, not natural numbers, the sum of first n terms, whatever may be the terms. Okay. So let us see here. AP given to us is A1, A2, A3 up to n. So an here represents the last term. Sum of all this is nothing but sum is given by A1 plus A2 plus A3. It continues up to an. So let me write this sum as also you can know that sum also can be this an plus an minus 1 plus up to this, and here if it is an here, okay, an minus 1, it continues up to a3, a2, a1. Is it right? So if I reverse this AP, it is an and here it is a1. Sum of these terms is same as sum of these terms, isn't it? Now let me write these two sum in terms of a and d and then add it. Let us see what we get. Let S represents the sum of a1 to an terms. What is a1 here? A plus d, a2 is a plus d, a3 is a plus 2d, plus it continues. What is an? A plus n minus 1 times d. Is it correct or not? An is equal to nth term, which is a plus n minus 1 into d. Similarly, the sum also can be represented at, write that first term. An here you can write an plus an minus 1, it will continue up to a1. So this is a plus n minus 1 times d. Okay, plus what is the next term here? A n minus 1, a plus n minus 1 into d. A plus n minus 1 minus 1 into d. Is it right? It will continue like this. It will continue like this, and finally you end up here with a, that is the last term. Now if I add these two, what happens? Let us see. By adding these two, s plus s here 2s equals, I'll add here and write the terms here. A plus this term, a plus this one is a plus n minus 1 times d. So this is 2a plus n minus 1 times d. So here it is 2a plus n minus 1 into d. So this is the first term. Second term is this one, a plus d, and this term I'll add a plus d plus a plus into bracket n minus 2 times d, n minus 2 times d. Now here a plus a, 2a plus d plus n into d minus 2d. So this is 2a plus minus 2d plus d is minus d plus nd. So this, if you simplify, it is 2a plus you take d common, it is n minus 1. First I will write nd and minus d, take d common, n minus 1. So the second term is 2a plus d times n minus 1 plus 2a plus n minus 1 times d, second term. So similarly you work out third term, and finally I will work out the last term over here. What is the last term here? A plus n minus 1 into d plus a here. Here itself I write plus a. So a plus a, 2a plus n minus 1 into d. So last term is 2a plus n minus 1 into d. So very interestingly, the way we found there 101, here we are finding 2 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus 2a into n minus 1 d, and finally the last term also this one. So you tell me how many times these terms are there. As there are n terms over here, the number of terms present over here are n times or n terms are there, and therefore n times this single term is nothing but the 2s here, the sum. Are you able to understand how many such terms are there? All these are same. Do you find out? You see 2a plus n minus 1 into d, 2a plus n minus 1 into d, finally 2a plus n minus 1 into d. How many such terms are there? N terms are there, and therefore n times this gives you the sum over here, and therefore I'll write here finally, therefore this 2s equals n times 2a plus n minus 1 times d. So finally what is the formula? S is equal to n by 2 into 2a plus n minus 1 into d, and therefore sum of first n terms, or S I'll write here, n by 2 into bracket 2a plus n minus 1 into d. Is it right? And this sum is nothing but the sum of first n terms, a plus t, a plus 2d, up to how many terms? Look here, up to n terms, and therefore we represent Sn here. The meaning of Sn is sum of first n terms, and sum of first n terms is given by n by 2 times 2a plus n minus 1 into d. And this is how we applied the same concept as that was used by a 10-year boy, Carl Friedrich Gauss. You understood? And therefore, even though the derivation for Sn is equal to n by 2 times 2a plus n minus 1 into d, it is not there for you people. The derivation will not come. But it is interesting fact to know that a 10-year boy's concept has been adopted to find out the sum of first n terms of an AP, isn't it? So I am using this formula to find out the sum of first n terms henceforth. So once again, I'll write this formula properly, and that you need to note down. So this proof is not required. I hope you have understood, and let me erase this one and take up the main formula. About 3 formulae are there which you have to remember, and then I'll proceed with numericals. Okay. Now let me write the formula here. Given AP is A1, A2, A3 up to an. These are the terms of the AP here, and in this one, sum of first n terms, sum of first n terms is represented by Sn, which is nothing but A1 plus A2 plus A3 plus up to an, and this is given by the formula which we derived earlier. Sn is equal to A is the first term. Please remember, A is the first term and D is the common difference. So I'll write here, if this is the arithmetic progression, then let A1 equals A and common difference, and D be the common difference. D equal to common difference. Common difference. So under such conditions, Sn is given by n by 2 into bracket 2a plus n minus 1 times d. This is the formula that we use to calculate the sum of first n terms. Please remember, this is the formula that we use to calculate the sum of first n terms. Okay. Now I'll modify this a little bit and see very interesting fact over here. This formula I am modifying, and we will arrive at one more formula for Sn. Look here, I hope you understand. N by 2 into bracket, this 2a can be split into a plus n minus 1 times d over here. Now already you know that this is nothing but this represents the nth term, which is an. Is it not? We have studied in the beginning, an equals a plus n minus 1 into d, and therefore Sn is given by n by 2 into bracket a plus an. Is that right? Dear students, you must remember an here is the last term. Is it not a last term? Is it not a last term? Sometimes the last terms are represented by am or l, and therefore the same formula I can write as Sn is equal to n by 2 into bracket a plus l over here. And this is one more important formula which we have arrived at. So this is the one more important formula which you have to note it down. Here L is nothing but the last term. Here L is last term. Sometimes the last terms are also represented by an or am also. Please remember am also. So either an or am or l, these are different notations. Most often we use either an as the last term or l as the last term. So in an arithmetic progression, if you know the first term a1 and if you know the last term, then this formula can be used in order to calculate the sum of n terms or the sum of the terms between the first term and the given last term. The sum of terms between the given first term and the given last term can be found out by using the formula Sn equals n by 2 a plus l. Here, you know, very interestingly, you need to know only the a and l. Of course, n is to be known. N is nothing but the total number of terms. If you know the last term and the first term, you can definitely calculate the number of terms by using the formula an equals a plus n minus 1 into d. Is it not? Because it is, after all, it is there in an arithmetic progression. So we arrived at second formula Sn equals n by 2 times a plus l, and these two are most important formula. You first note it down. And one more formula, how to obtain nth term, which is the general term, nth term in terms of the sum of n terms. This formula is very important. Many students neglect this formula and end up in a soup. Very important is it is given in your textbook. You can find it out, and we'll try to derive that expression, that equation also, and we'll see how to use that formula also. So two formula, one more important. First you note it down, then I'll discuss. Here, dear students, I'll take one small example. 1, 2, 3 up to 10. Is this a sequence of numbers? Is it in arithmetic progression? Yes. First term is known to us, last term is also known to us. The common difference is 1 everywhere here, and therefore this is in AP. Now, sum is given by 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Let me write this one, and also I'll write the terms here: A1, A2, A3, A4, A5, A6, A7, A8, A9 and A10. There are 10 terms over here. Now, what is the first term? A1 equals A equals 1. What is the common difference over here? Common difference is 2 minus 1, 1. 3 minus 2, 1. Common difference equals 1. Let it be there as it is. Now, what is the sum of first one term? Do you understand? What is the sum of first one term? Sum of first one term is 1 itself. Are you able to understand? Sum of first one term is 1 itself. Okay. Sum of first two terms, 2 plus 1. Sum of first three terms, 3 plus 2 plus 1. Sum of first four terms, 4 plus 3 plus 2 plus 1. So you know how to calculate the sum of given n terms. Here also it is very simple. Sum of first 6 terms, can you calculate? 6 plus 5 plus 4 plus 3 plus 2 plus 1 is the sum of first 6 terms. Now, I am not interested in sum here. I am interested in to find out fourth term. Do you understand? I want to find out the fourth term in terms of sum here. Very interesting. See here, I want to find out fourth term. Find fourth term in terms of sum. Find fourth term in terms of sum. So what I will do here is, where is the fourth term? Here is the fourth term. Fourth term is equal to sum up to 4 terms minus sum up to 3 terms. If I do that one, I'll get the fourth term. What did I say? Sum up to 4 terms minus sum up to 3 terms gives me A4. Are you able to understand here? Let me check whether it is correct or not. This equals, what is sum up to 4 terms? 4 terms. 4 plus 3, 7 plus 2, 9 plus 1, 10. Minus sum up to 3 terms. 3 plus 2 plus 1. 3 plus 2, 5 plus 1, 6. Which equals 4. Is it not the fourth term? Check here. This is the fourth term. What is the fourth term? 4. I got the value of the fourth term as 4. How did I calculate the fourth term? Fourth term equals sum up to 4 terms minus sum up to 3 terms. Let me calculate fifth term, A5. Can I do this way? Fifth term, if I want sum up to 5 terms, first 5 terms minus sum up to first 4 terms. Is it true? Let us take sum up to 5 terms. 5 plus 4, 9, 12, 14, 15 minus 4, 3, 2, 1, 10, which equals 5. Yes, perfectly I am getting the answer. See, very interesting. If I want to find out 5, A5 or fifth term is 5 here, and how did I obtain? Sum up to 5 terms minus sum up to 4 terms. Let me find out A8. A8 here is the 8th term. What is A8th term here? 8 I should get. So can I do like this? S8 minus S7. Let me check up to sum up to 8 terms. 8 terms. 8 plus 15, 21, 26, 30, 33, 35, 36. Let me check. 36 minus 11, 22, 25, 27, 28. Check here. 36 minus 28. How much it is? 8. So is 8th term 8? 8th term 8. Perfectly alright. Very interesting, no? You are able to find out any given term by taking sum up to that term minus the previous sum up to previous term. A4 equals S4 minus S3. A5 equals S5 minus S4. A8 equals S8 minus S7. And I'll continue. A9 equals S9 minus S8. A10 equals S10 minus S9. And it will continue. AN equals SN minus, here if it is 10, here it is 9. Here if it is 9, here it is 8. Here it is 8, it is 7. If it is 8, 1 less. If it is 9, 1 less. If it is 10, 1 less. If it is n, 1 less. Yes, n minus 1. Dear students, this is the formula that I was interested to talk about. Therefore, nth term can be given in terms of sum of n terms as n equals Sn minus Sn minus 1. Very interesting. So this is to be noted down. Once again, I'll erase this one and write it down. This is called nth term in terms of the sum of n terms. Is it clear? So I'll write the title and then this right formula you have to note down. Or here itself I'll write it so that you can note down this part only. Okay. What is that we wanted to write? So, nth term in terms of sum. Nth term in terms of sum. An equals Sn minus Sn minus 1. Most important formula. Please do not neglect. In your textbook, I use this quite frequently also. In your textbook it is given and this formula is used quite frequently. If this is not clearly visible, once again I am writing here with a blue. An equals Sn minus Sn minus 1. Most important formula. Many students neglect this. Believe me, 1 mark question will come for this. They will never be able to solve. You must remember this one. So, can I list down the 3 formulae, most important 3 formulae that we encounter in the second section. Let me check up that one. So first you note it down. I think it's okay. I'll write here once again the 3 important formulae that we need to note it down for the second section. So the first formula, sum of first n terms. All these sum and all are applicable only for arithmetic progressions. Dear students, if the given list or whatever this a1 plus a2 plus a3, what I am talking about, that a1 plus a2 plus a3, if you take into account only a1, a2, a3, that list should be in arithmetic progression. Only in that case, the sum of such terms which are in AP is given by this formulae. We are talking about arithmetic progressions, remember that. And therefore, here first one, sum of first n terms. It is given by the formula Sn equals n by 2 into bracket 2a plus n minus 1 into d, where a is first term, d is common difference, Sn represents sum of first n terms, and n represents number of terms. Is it clear? 1, 2, 3, 4. Please remember, out of these 4 variables, if you know 3 variables, you can calculate the 4th variable. Repeat, out of these 4 variables in the given formula, if you know 3 terms, you can calculate the 4th term. In order to calculate the 4th term or one term, any one term, you must know 3 terms over here, and this is important, you must know. Second one, the same sum of n terms is given in terms of the first term and the last term. Also, Sn equals n by 2 into bracket a plus l. Okay, this also is represented by Sn equals n by 2 into bracket a plus an. Please remember, both these you need to remember this. L is nothing but an is nothing but l, which is last term. And finally, this is the formula, third one. And finally, this is the third formula, isn't it? So 1, 2, 3, these 3 formulae are the one which you have to remember. First, you note it down, and then directly I'll go to solving the numerical. One more property is very important property. First, you note it down. It is not related to the sum and all, but it is related to arithmetic progression. That property also I'll discuss here itself after noting down this, and then I'll proceed to solve the numericals from your textbook first and then RDS. Okay, note it down first. Dear students, I am going to discuss one important property. This is for the knowledge point of view, and probably you may or may not get a question, but you must know about this. So let us see what is that one. If a1, a2, a3 is in AP, then by adding or subtracting or multiplying or dividing the given list of numbers by any non-zero constant also results into a new arithmetic progression. Are you able to understand what I am talking about? If I have been given a non-zero constant k, add to each term here k, then the resulting sequence is a1 plus k, a2 plus k, a3 plus k continues, isn't it? In that case, that sequence also represents an arithmetic progression. Same is applicable for multiplication, subtraction and division. So I'll write here if k is a non-zero constant, then following are in AP. Following are in AP. Then following sequences are in AP. Following sequences are in AP. Which are those sequences here? First one, A1 plus K, A2 plus K, A3 plus K, An plus K. The sequence that is resulting is also in AP. Second one, A1 minus K, A2 minus K, A3 minus K, An minus K. This sequence is also in AP. Third one, KA1, KA2, KA3 and KAN. This also is in AP. And finally, A1 by K, A2 by K, A3 by K and En by K. This sequence is also in AP. That means if each term of a given AP is multiplied, divided, or to those terms if a non-zero constant is added or subtracted, the resulting sequence of numbers, the resulting list of numbers also will be in arithmetic progression. Okay, this is one property. You must know this one. Probably I may come across few numericals based on this property. We'll see that one, but for your knowledge sake, you must remember, because even in ICSE standard 10th standard, whenever they discuss the arithmetic progressions, under the heading that is properties of arithmetic progression, this important property is discussed, and we may or may not come across, but for the knowledge sake, please note it down. Okay, students, before we start the exercise questions, I have a couple of numericals here. The sum of first n natural numbers, sum of first even natural numbers, sum of first or sum of n odd natural numbers. So sum of n natural numbers, sum of even natural numbers, sum of odd natural numbers. Let us try to arrive if we can get some formula here. Okay, first one, sum of n natural numbers AP 1, 2, 3 up to n. So these are natural numbers up to n, and this is in AP because common difference is 1, and hence it is in AP, and therefore A equals 1, D equals 1, and sum of n is given by 2A plus n minus 1 into D. This is, just a moment, n by 2 into n by 2 times 2A plus n minus 1 into D. This is the formula which is sum of first n natural numbers we are using, which equals n, of course, as it is n, divided by 2 into bracket 2 times A, 2 times 1 plus n minus 1 times D is 1, which equals n by 2 into bracket 2 plus n minus 1, which equals n by 2 into bracket 2 minus 1, 1, or n plus 1 can I write here, which is equal to n into n plus 1 divided by 2. So this is sum of first n natural numbers. Okay, now next let me take here second one, sum of even natural numbers, sum of n even natural numbers, sum of n even natural numbers. What is the first even natural number? 2 it starts with. So AP, that also forms an AP. 2, 4, 6, 8 continues up to n. Here a equals 2 and d equals 4 minus 2, which is also 2. Therefore Sn is given by the formula n by 2 into bracket 2a plus n minus 1 times d, and this equals n by 2 2 times 2 plus n minus 1 times 2, which equals n by 2. Here it is 4 plus 2n minus 2, which is n by 2 into bracket 4 minus 2 is 2 plus 2n, isn't it? Now what should we do? This is written as n times 2n plus 2 the whole divided by 2. Now I'll take 2 common here. 2n n plus 1 divided by 2 cancels, n into n plus 1, and therefore sum of first even natural numbers is given by Sn equals n times n plus 1. You take any value. Can we test it over here? You take n is equal to 1. 1 into 1 plus 1, that is 2 into 1, 2. Is it not even? Yes. Take n is equal to 5. You take odd itself for checking. 5 plus 1, n is equal to what I am taking? 5 I am taking. So 5 into 5 plus 1, which equals 5 into 6, which is 30 even number. You take n as an even number. What is n? You can take 8, you take it. So yes, 8 equals 8 into even numbers I am talking about. Okay, sum of even this thing. So sum is equal to 8 into 8 plus 1, which is 972, isn't it? So sum of even natural numbers is given by n into n plus 1. Now let me take sum of n odd natural numbers. Next one, you can note it down, pause the video and note it down, all these things. I'll take over here sum of n odd natural numbers. Here this is sum of third one, sum of n odd natural numbers. Okay, we'll take this now. So what is the first odd natural number? 1, 3, 5 continues up to n. 1, 3, 5. 1 is the first odd natural number and 3 is the odd next natural number. The least is 1. So a here is, this is in AP. Is it not in AP? Common difference is 2 everywhere for here. So a equals 1 and d equals 3 minus 1, which is 2, 5 minus 3, which is 2. Now Sn is given by n by 2 into bracket 2a plus n minus 1 into d. This is the formula that I am using now. N by 2 into bracket 2 times 1 plus n minus 1 times 2 over here. This is n by 2 into bracket 2 plus 2n minus 2. This 2 cancels, which equals n by 2 into bracket 2n, which can be written as 2n square by 2. 2 cancels, n square. What an interesting formula. Sn equals n square. Let me check whether it is correct or not. Correct. 2 plus 2n minus 2, 2 cancels, 2a it is 1, it is correct, and 2n, and therefore this one. Order. Say for example 1 square 1. Sum of odd natural numbers 135, isn't it? So I'll take something like this. Is it correct or not? How do you validate here? Any numerical is there in that one? No. Anyway, we'll try to validate later, but first you note it down. Sum of n odd natural numbers, which is given by n square over here. Okay, fine. Now we'll solve exercise 5.3, which you can have a look at. I think it is visible. 5.3, first main, 4 sums are there. I'll take up second and fourth. What is the question? Find the sum of the following APs. So already he has given that these are in APs. I did not check whether the given list of numbers is in AP or not. If they do not give that the list of numbers is AP, in AP, then first you have to validate that it is in AP, and then you can take up the sum of first n terms. Okay, here find the sum of the following APs. Second and fourth I'll take now. exercise to 5.3, and out of this one I am taking first main, second one. AP given to us is minus 37, minus 33, minus 29, it continues. And how many terms? 12 terms. What is that we have to find out? Sum of the following APs up to 12 terms. So I have to find out, these are the terms given, up to 12 terms, the sum needs to be found out. Or sum of first 12 terms is to be found out. That is the question asked. So A equals minus 37, D equals minus 33, minus of minus 37, minus 33 plus 37, which is plus 4. 37 minus 33, which is 4. So I have got A is minus 37, D is equal to 4, and what is N is equal to? 12 terms, N equals 12. Therefore, sum of first 12 terms is given by, Sn is given by n by 2 into bracket 2a plus n minus 1 into d. This is the formula, and therefore S12 equals 12 by 2. Wherever n is there, you replace by 12 first. 12 by 2. 2 times A is how much? Minus 37. Plus n is 12 minus 1. D is plus 4. So let us solve this one. 6 into bracket. This is minus 70. Minus 74. 12 minus 1, 11. 11 fours are 44. 44, which equals 6 times minus 440, 743 minus 30, which is minus 180. Sum of first 12 terms, S12, is minus 180. Check this, it is correct. Next one. Fourth question. AP given to us is 1 by 15, 1 by 12, 1 by 10. It continues up to 11 terms here. So I have to find out sum up to 11 terms. For that I have to find out A, 1 by 15, D equals 1 by 12 minus 1 by 15, which equals. So what is the LCM over here? 12 and 15 LCM 30, 36, 45. So 15, 5 into 3, 3, and 12 can be written as 2 into 3 into 2, 2 square into 3. So this is 12, 15 is 3 into 5. So what is LCM here? 2 square into 3 into 5. 4 into 3 into 5, which is 60. 60. Yeah, which is 5 minus 4, which is 1 by 60. So the common difference is 1 by 60. Is it clear? So let us check 12 and 15. 12 and 15. You can do this way also. 3 4s are 5s are 2 2s are 5, 2 1s are 5. Correct. Now common difference we have found out, which is 1 by 60. Okay, fine. Anyway, it took time. It's okay, no problem. We have to solve this, no? Next, 1 by 60 is the common difference. What is n here? 11 terms. Therefore, sum of first n terms is given by n by 2, 2a plus n minus 1 times d. This is the formula. Here we have to find out sum of first 11 terms. S11 equals 11 by 2 into bracket 2 times 1 by 15 plus n is 11. 11 minus 1 is 10. 10 times d. d is 1 by 60. 1 0 1 0 cancels, 1 by 6. 11 by 2 into 2 by 15 plus 1 by 6. So here 11 by 2 and LCM is 30, correct? No, 15 2s are 6 5s are, so 4 plus 5, which equals 11 by 2 into 9 divided by 30, which equals 3 1s are 10s are 3 3s are 9, isn't it? So 33 divided by 20. Yes, 11. No, we have got a wrong thing. Let me check it. I think something is wrong. Is it how much it is? 33 by 20. It is correct. Yes, 11 is equal to, because all these are in fractions and therefore we are getting the correct answer. It is correct only. Note it down. Next I will go. First you note it down, then I will take up the next sum. Second main exercise I have written here 5.3. 5.3 second main. Find the sums given below. This one, this one, this one. Which should I take? You can, okay, I will take up this one. This is minus 230, okay. This you should be able to do it. Third one I will take. First, second, you do yourself. Third one, second main. Third one. Find the sums given below. This is what it is. What is given to us is minus 5 plus minus 8 plus minus 11 plus up to minus 230, minus 230. Is it in AP? Let me check it. Here D equals minus 8, this term minus this term, minus of minus 5, which is minus 3. Let me check one more D, minus 11 minus 8, minus 3. And therefore, as the common difference is constant, the given series, it is in AP, okay. Therefore, given series is in AP, or the given list of numbers is in AP. I can write that way also, or also you can write given list of numbers is in AP, and therefore we can apply the formula over here. So therefore A equals minus 5, D equals minus 3, and sum of how many terms, that is also very important. So we have to find out n here, because last term is given to us. You have to find out n, or we have one more formula, A plus L, and therefore I will write here L equals minus 230, and therefore sum of the terms is given by sum of terms is given by, we have to find out n also. Just a moment, n also we have to find out. To find n, let an equals minus 230 implies a plus n minus 1 into d equals minus 230. What is a here? Minus 5 plus n minus 1 times d is minus 3 minus 230 minus 5 minus, I'll take this side, 3 times n minus 1 equals minus 230 minus 5 minus 3n plus 3 minus 230. So minus 5 plus 3 minus 2 minus 2 minus 3n equals minus 230, implies take this 3n that side and this side, minus 2 plus 230 equals 3n, which equals 230 minus 2, 228, 228, and therefore n equals 228, 228 divided by 3 here, which equals 3 7s are 21, 18, 3 6 are 81. Therefore n is equal to 76. How many terms are there in the given series? Basically there are 76 terms. Therefore sum from minus 5 to minus 230 is nothing but sum of 76 terms. Okay, as there are 76 terms, as there are 76 terms, sum of 76 terms is given by first general formula I will use. Of course you can use the other formula. Sum of 76 terms is given by Sn equals n by 2 a plus l. Here S76 is equal to 76 by 2. A is how much? Minus 5, and plus L is minus 230. Minus 230. Yeah. And therefore S76 equals 76 by 2 is 38. Correct, no? Now here minus 5 minus 230. 38 into minus 235. So 235 into 38 I'll do here. Until 40, 4 8 24 until 44 8 24 28 2 2 16 2 8930. Check it. How much you read? Minus 8930. Therefore, S76 is equal to minus 8930. Minus 8930 is my answer. Therefore, what is the question asked? Find the sums given below. Therefore, sum equals S76 equals minus 8930 is my final answer. Okay, so what we did here is, we know A, we know D, we know last term. I can use this formula, but n I did not know. Therefore, to find out n, what I did, let nth term be, or the last term be, minus 230. So by applying that nth term formula, I could find out the number of terms which is equal to 76. As there are 76 terms, sum of 76 terms of the given series is given by, this is the general formula, and S76 is given by this. You understood? Generally, this formula is to be written first. I can write something like this also. Sum of n terms is given by so and so, and therefore sum of 76 terms. It is better to write that way rather than this way. What is this formula? Sum of n terms is given by, and therefore sum of 76 terms is given by, something like that. But it's okay. I think it implies here, and therefore, so note it down.